Finding the time given an exponential function with base e that models a real-world situation. So for the fourth topic of this model, we have a problem uh, which says Henry places a bottle of water inside a cooler. As the water cools, its temperature, C of t, in degrees Celsius is given by the following function. We have the function there, which is C of t equals 10 plus 12 e to the minus 0.03 t, where t is the number of minutes since the bottle was placed in the cooler. Now, Henry wants to drink the water when it reaches a temperature of 15 degrees Celsius. How many minutes should he leave it in the cooler? So basically, Henry has this cooler where he places a bottle and he likes to drink his water when it is at 15 degrees Celsius. If it is warmer or if it is colder, well, it won't work. So we want to find, given this function, at what time this will happen. So this is a simple equation. That gives us the temperature depending on the time that we are given. So we have the function C for Celsius, T for time, equals 10 plus 12 e to the minus 0.03 t. We know that the temperature that Henry likes is 15. So we know that this function, C of t, has to be 15. Okay? If you look closer, we have here two equations. Here, this one, and here, this one. And we have one common term. This common term is C of t. So we can go and say that our equation, 10 plus 12 e to the minus 0.03 t, has to be equal to 15. All I am doing here is stating that my function here has to be the value 15, because 15 is the temperature that Henry likes. But I want to know when this happens. When is t 15? Well, maybe the hardest part of the problem is explaining the problem, making this problem into math. But you are given already a function, so you just have to make it equal to the value that Henry wants. Now from here is just a simple exponential equation in which I want to solve for t. I want to solve for t. T needs to be alone, but I have here a 10 and here I have some numbers that are not letting me work, so I'm gonna move them to the other side. First I will move this 10 to the right side and I'm gonna have 12e to the minus 0.03t equals 15 minus 10. 15 minus 10 is 5. I will continue here. This 12, it's multiplying my e, so I don't want it there. I move it to the right, dividing. So I will have here on my left side my e, just like that. And on the right side, I will have 5 over 12. Yeah, this 12 here, I move it to the right side. Now, as you remember from the previous model, exponential and logarithmic equations, whenever I have the number that I want to solve for in the exponent, I need to apply logarithms to leave it alone. I will apply a natural logarithm because the base of this exponent is the number e. Anytime I have that, I apply natural logarithm. So I will apply a natural logarithm in both sides of the equation. I will have the natural logarithm of e to the minus 0.03 t, which equals the natural logarithm of 5 over 12. Just like that. And here I will apply the power rule, which is a property of logarithms. If you remember, we call it the power rule. The power rule, I will make some space here so that you remember, says that whenever I have the logarithm of a number, let's say, for example, 8, raised to a power, for example, x, we can move this exponent down here. So because of this property, I should write it like x times natural logarithm of 8. Yeah, that's the power rule, in case you forgot. I will apply that here. I will take this exponent down, so it will look something like minus 0.03 t natural logarithm of e equals natural logarithm of 5 over 12. All right? Now, I know for sure that the natural logarithm of e is always 1. Always. Natural logarithm of e equals 1. Yep, don't forget that. Okay? Now, I can rewrite only minus 0.03 t equals the natural logarithm of 5 over 12. The only thing that I need to do here now is take this number to the right side. So I will have t equals natural logarithm of 5 over 12. And all of that divided by minus 0.03. All right. For this one, Alex is asking me to give an approximation. So I have to round this number, but first I need to compute it. So I will use the Alex calculator, and I will have the natural logarithm of 5 over 12, all of that over negative 0.03. Solve it, and this is 29.18. That is the number that I want. That is the time in which the temperature reaches 15 degrees Celsius. Check, yeah. We have to round it, remember. 28, when we want to round it, we round it to 29.2. So that's the answer for this exercise. After 29.2 minutes, Henry can drink his water at 15 degrees Celsius.